All right, well, thank you to the selection committee for bringing me on the stage again. I have spoken at previous CDCons, and I always enjoy being here. I was just telling somebody at lunch, this is really my only technical conference I go to. Some of them are too big. I really like the size of this one because I think we get a lot done when we have discussions, and the hall track is much easier here than it is at KubeCon, to be quite honest. So let's talk about vulnerabilities for a minute. I know that you probably hear about them all the time, but there's a reason for it. They're very expensive. According to IBM, they did their data breach report and their X-Force report, and they claim that data breaches are costing about $5.5 million annually per enterprise, which equates to about $9.5 trillion globally, which I think is an interesting number because if you went to the keynote this morning, we learned that open source has saved something like $8 trillion. So if we have $10 trillion of open source vulnerabilities coming through the supply chain, there may be a reason why we shouldn't use open source. And we don't want to go down that road. We need ways to fix these. We need ways to score them. And that's really what the Ortelius project is all about, and what other projects within the Linux Foundation is working on. Important to realize is that it takes about 100 days to respond to a vulnerability and about 10 days to exploit it. I am Tracy Ragan. I work with Steve Taylor at DeployHub. We are co-founders of DeployHub. As he mentioned before, we had a company called, it's actually still around, it's been there for 30 years, OpenMake Software, where we generated build control files, or what you may have known as make files or AND scripts. So we have this thing about liking to generate these types of files, and that's going to be important as you learn more about Ortelius. I'm on the governing board of the Open Source Security Foundation. I actually helped start the Eclipse Foundation, and I'm also on the CD Foundation's Technology Oversight Committee. So how many of you know what OpenSSF Scorecard is? Okay, so some of you do. I'm glad that I'm going to bring some new information to those of you who don't know. It's a framework for assessing the I would prefer to call it the compliance level of open source code. How compliant are these open source packages and open source solutions? A solution would be like Ortelius is not just a package, it's a solution. How compliant are they in terms of securing their code? And there are several different steps, we'll go over some of them, in the framework that evaluates that. Ortelius is an open source solution that continuously monitors vulnerabilities, in particular post-deployment. In our world, we say fix it fast or risk attack. And we are getting inundated with vulnerabilities, so how do you make it that you can respond quickly when a new vulnerability is found and it's running in your production environment? It's running on live endpoints. That's what we're addressing in the Ortelius project. And then Jenkins has always been our powerhouse for CI/CD automation, workflow automation. So I'm going to combine all these three together, and I'm glad that we have had some previous Jenkins speakers to talk about how important that is. Whoops, sorry. I'm showing everybody my, okay. All right, so how compliant is the OSS you use? That is the question we should all be asking when we're consuming open source objects. But it's really, really a difficult thing to do. It's almost impossible. This OpenSSF Scorecard was developed, was originally the baby of Jamie Thomas from IBM. She was one of the first chairs of the Open Source Security Foundation, and she really pushed, let's just get some compliance levels up there for open source packages. It uses many, many measures, but I kind of select 10 of the ones that are the most popular to evaluate how compliant your open source is. And if you want to learn more about the scorecard, you can go to the OpenSSF.org, or you can go to securityscores.dev to pass in information about the package that you're using. Okay, so Steve Taylor covered many things around zero trust. There may be some overlap between here, but for the most part, this isn't about zero trust. This is simply about compliance. What are the open source packages doing within their GitHub repo that you can see that makes them more a safer bet than other open source packages? Code quality. Checking for code vulnerabilities and potential security issues. And there's different scanners that can do this, but this one just checks to see the work you're doing. Dependency management evaluates the project's ability to manage and update dependencies. License compliance, what's your licensing that you're using, which may be coming from an SBOM, but the scorecard's going to go check on it from within your repos. Disclosures. Do you have a process for disclosing security vulnerabilities on a fairly regular basis? I'm not sure what the guidelines are now for an open source project, but they want you to disclose vulnerabilities within 7 to 10 days, and sometimes they want them fixed even faster. Is that possible? I don't know, but are we trying to do that? Is the repo set up to have code reviews? Does it have a CI/CD process to it? Are there GitHub actions? Is there a package manager associated to that checks for the project's package manager and its plugins? Does it have security policies built around it? Checks if the project has a security policy in place. Security testing and vulnerability scanning. And what you're going to get is a score based on all of these items. And that score is going to be shown to you in a badge within the repo. So if you're using iDNA, for example, you could see if they have an OpenSSF score. So to find that, you can use their scorecard value finder, and you add to that. For this example, I'm using Ortelius/ms-sbom export to say what is the value, the scorecard value of this particular object. And it will give you that value. So you can see Ortelius' scorecard value for this particular object. It's not perfect in terms of what it can show you. Like we have code reviews, but it can't determine that. But it gives us a general score of 7.5. Now, let's talk about Ortelius for just a minute, and then we'll get back to the scorecard. So what Ortelius is doing is Ortelius is really focused on post-deployment vulnerability detection. We consume those crazy SBOMs that Steve was talking about, and we consume where the endpoints are. When a deployment occurs in the pipeline, we track where the endpoints, what endpoints were used based on the log file. So that gives us where it's been deployed, and it gives us the open source packages that the application is consuming, or the component, whatever was built. With those two pieces, we can now scan OSV.dev and synchronize on a regular basis and say, by the way, you have production problems because these are new vulnerabilities you didn't know when you ran the build. That's what it does. And we're incubating at the Continuous Delivery Foundation. We've been there for about 4 years. So synchronizing against OSV.dev every 10 minutes is really kind of the key here. We believe it's the key. Because right now, we have about 40,000 vulnerabilities coming across the supply chain annually. And we cannot expect the development teams to spend their time fixing about 100 vulnerabilities a day. So which ones are critical? Which ones did we miss? Which ones impacting us right now? And how do we get them fixed? So by marrying the SBOM and the deployment data and OSV.dev, we can deliver that continuous checking. Now keep in mind, we don't do a scan. We don't have a runtime scanner that gets installed into a container. We gather the information during the at the DevOps pipeline and almost create what we like to call a digital image of the configuration of what's running in production, which allows us to do that scanning and constant reporting. So when we do that, we can detect vulnerabilities and we can identify them based on an application. Now, an application is kind of an obscure thing anymore, right? Because what we have are components. And in a decoupled architecture, you could have hundreds of components that make up a single application. which means that we have hundreds of SBOMs that make up a single application SBOM. So we aggregate that data, and there's other tools that do that. I think that OpenSSF has one called bomb control. But we aggregate that data up to that higher level order. Now, as an application team, you're wanting to know what your application vulnerabilities are, not just one lower level component that you, in fact, might not even develop, you just consume. And that has its own SBOM, that has its own OpenSSF score. So we consume that data up at the application level, and over on the left-hand side here, you'll see the components OpenSSF scorecard for that application. So we're gathering the SBOM data, we're gathering the package data, and we're gathering the SBOM data so that you can see everything at the same time, as opposed to looking at one package at a time. I don't know how many packages that this particular application uses, but I'm guessing it's at least 70 to 80 packages. So instead of looking at them one at a time and having a human determine that, we just aggregate it and we display it for you, which allows us now to do a package search. So you could ask Ortelius, where is iDNA running? And it would give you a list of every single object that's running in production that is using iDNA. So if iDNA had a vulnerability in a particular version, you could ask Ortelius, where is this running? And it would expose that for you. And somebody asked about Guac. Guac does something similar. We do show the blast radius, but what we're showing is the blast radius of a package that's been impacted, and the component that's being impacted, and the applications that are being impacted by that component. So we use Ortelius to aggregate the scorecard results. That's kind of the important part of this presentation, is because while the OpenSSF Scorecard is extremely useful, it can be hard to understand it if we're not aggregating it to a level that's understandable from the user's perspective. And in our case, the user is the application team. We also show it from the component side. We call it a logical application. And if somebody has a different word for it, please tell me, because how else do you describe a modern application and a decoupled architecture? Is it the one component that you're creating, or is it the collection of components that make up a solution delivered to an end user? In my world, that's the level that we need to start understanding vulnerabilities, because that's who we're impacting. Those vulnerabilities are being consumed by our end users, not just a single component. So we do both levels. So we first gather the component OpenSSF scorecard information, providing all the details of the score from that OpenSSF scorecard for the component, and then we aggregate it up to the higher level. We also aggregate SBOM information. So we're taking the package information and we're making it useful for both SBOM reporting and OpenSSF scorecard reporting. So how do we put it into your CI/CD workflow? Not terribly hard. I think Steve pointed out, I don't think he had enough time to go through all of his pieces, but some of those pieces showed the command line for doing that. So we gather information at both the build and the deployment. And if no SBOM exists, we do generate a SIFT SBOM for you. So if you're not creating SBOMs today, we would create that for you as part of your plugin to, or your command line interface to Jenkins. So why should you gather this? It's because what you're attempting to do is pinpointing the impact of a new vulnerability across your live environments. So this is where we're now stepping in from being DevOps engineers, really, and being able to report on what's happening in production without ever having to scan production, right? So we've gathered it and we're just letting them know, because we're aggregating those full insights of all the open source packages that the DevOps pipeline is consuming to build a container and where it's deployed. So how does Ortelius do it? So first thing that we do is we consume the data coming from the DevOps pipeline, including the gathering of SBOMs and deployment locations. We scan OSV.dev on every 10 minutes, which allows us to map the new threats and map the attack surface. Now, what we're working on, and we'd love to have anybody, and everybody, if you go to a presentation presented by an open source team, we're going to ask for help. So I'm asking for help now. There's quite a bit to do in this area. There's many ways that you can contribute in open source, but we would hope that you would be interested in joining the Ortelius team. So what we're doing, we have now a mapping, right? We know what the blast radius is. We know where open source package vulnerabilities are running in live environments. The real important step is fixing it. Let's just go out and fix it. Now, how do you fix these? For the most part, you have to update the pinning of the version of the package in your package manager. And because, in particular, in a Kubernetes or a decoupled architecture, you could have hundreds, if not thousands, of package managers building different containers that need to be updated. So what we're working on now is building an MCP server that will go out, find the correct version of the package that you should be using, going and finding those packages in the repos. If at the enterprise level, we can scan an entire repo, update the pinning, and create a pull request. We also want to determine if there could be potentially breaking changes. And if there is, then we would create an issue. And we would do this for two things: critical and high-risk vulnerabilities that are impacting your production environments. I honestly believe that in order to cut down on the noise and to start responding more efficiently to these vulnerabilities and making it safer to use open source, that we just have to figure out a way to fix it fast. It's chaos engineering. What do you do to fix it fast, get it fixed, and then later figure out how it got there? We don't need to know the root cause right now. What we need to know is how to get it fixed. And if we can fix 50% of these vulnerabilities by correcting the pinning in the POM file, we're doing a lot, right? We're doing a lot, especially if you're looking at 40,000 vulnerabilities a year, even if we did 25%, or just the critical and high risk, which runs about 10%. We've made a big step in being able to reduce mean time to remediation from 100+ days to less than 10, at least. Probably less than 5. So some takeaways: use OpenSSF Scorecard. If you've never played with it, I would play with it. I would look to see, if you're working in an open source project, if you're building components for your own company, you can use OpenSSF Scorecard to evaluate what you're doing. Use Ortelius to report high risk and critical vulnerabilities, and to understand what components need to be patched quickly, because that's kind of the essence of it. And automate this through your pipeline. We don't need to be doing this manually. And we really would love to have about 10 companies who want to get involved in this project and be adopters of the process, because that's the way we are going to be able to sort out how to do the auto remediation. And the auto remediation moving forward will be critical to all of us. So please, if you're interested, reach out to myself, reach out to Steve Taylor, go to Ortelius.io, and you will learn a lot more about it. And this is how you can reach out to me. Now, the biggest selling point for today is tomorrow in this room from 12:30 to 2 o'clock, which is your lunch break. I'm encouraging you to go grab your lunch, get your box, come back into this room, and we are going to have a heart-to-heart conversation about what cybersecurity needs to look like in the CI/CD pipeline. We're going to talk about software debloating. Does anybody know what software debloating is? It's pruning of open source packages. We have spoken about this over time, and it is a cultural thing with us. We don't like the idea of taking out a package because maybe you might need to use it. We're going to talk about CI/CD, MCP servers. We're going to talk about how to better add components to your CI/CD pipeline. We're going to talk about AI, and we're going to talk about auto remediations. So please come, have a discussion with us about what it really needs to look like in the CI/CD pipeline. And thank you. Oh, we did? Okay, I thought I was going to be late.
No, you actually started early, which is great. So we have enough time for some questions. If I can get the mic on real quick. We have enough time for some questions, and then I'm going to release you. Hey, I'm right there in front of the microphone, in front of the, that's called a speaker. This is a microphone, that's a speaker. Yeah, open up for questions,
Absolutely.
And then I'm going to release you for 10 minutes to grab, a cup of coffee. We'll take a short break, but
please ask a question and stump me. I would love it.
Ooh.
Yes.
Oh, so quick.
Kind of a random specific question about Ortelius, but when you run a report and it spits back data, like, just what does that actually look like? What's the format of the data? How can it be, read into like a GitHub Actions pipeline and then integrated into that? Is it like HTML data that you can parse out, or is it meant to be run as its own like standalone service on the side?
It's so Ortelius is installed as there's a SaaS version of it you can go play on. You can install it on-prem. The types of data that we produce and the types of reports are basically where the vulnerability is mapped to the component, and the component is mapped to the endpoint. Okay. So it's pretty standard data format, just as literally as a table. Okay. Within that, we could generate more reports, and we could add reporting that shows the repo. It could show the Helm chart. It could show any data that we choose to collect. And we do collect a lot of DevOps data. We collect build data. We collect the commits. We collect a lot of that. But what we're really reporting on is the component, the vulnerability, and the endpoint.
Okay, thanks.
Yeah, and then we had another one right here.
Hey, so yeah, I'll definitely be back for tomorrow's lunch and powwow around the room here. But realizing that everybody probably uses different tools to kind of do some of these auto remediation things, I'm really interested in Ortelius in terms of like showing the value of what we're getting in the artifacts from the SBOM and the vulnerabilities. So could you use that? I mean, because I came to the conference not knowing anything about Ortelius, believe it or not. So could you just use that tool alone? Like if I'm using Trivy to generate my Cyclone DX, I could just use Ortelius to like consume that data and report on it, so
yes.
I can see the logical component mapping. I think is what, I don't remember if that's
exactly what we do.
Okay, That's really valuable because I've been trying to figure out a way to consume the data that I've been like doing build attestations and SBOM reports and things. But there's like no way to really like consume this very well. So, well, apparently there is, but I just didn't know of it.
That's what we decided we would do. We needed to consume the information.
That's great.
Vincent Dannon and I, when Executive Order 14028 came out saying if you work for the government, you have to give us an SBOM, we wrote an article that said, SBOM so far so good, so what? Because if you're not consuming the data, you just have a file that's hard to read in your Git repo. And if you really want to use it for anything, you're going to have to write a grep routine at minimum to go look for a particular vulnerability within it. Yeah, we store everything in Orango right now. But why not? It's a relational database problem. Exactly. Yeah. So yes, that's what we do, and we use the Helm chart to determine the containers at the higher application level. So we consume Helm in the CLI process. So it creates a component and it creates an application for you based on the Helm chart.
Hi. So last year when I attended, learned about the scorecard for the first time, and that was really exciting technology. But when I tried to incorporate it into some of my software supply chain management processes, I found that it wasn't adopted to the degree where I could operationalize it. Has that improved over the last year? What's the trends you're seeing?
You know, I should have redone my screen prints because I was looking at, going through what I needed to do, and I was looking at the live data. And I'm finally, after all this time, starting to see some of the open source packages have a yellow as opposed to red, right? So they're getting 4s and 5s. I don't know how many are getting 7s and 8s, but at least there's some adoption. And the reason why there's not a lot of adoption is because there's no visibility, and you have to go look at every single package. So we're trying to not go shame, 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 but say here is here's what it looks like for these open source packages that you're consuming. And if you're consuming them and they're not giving you a score, you might open an issue. But you don't know unless you go through that one big URL and say, go find the score for me. So that's why we're aggregating it.
All right, one last question here. Yeah, you can shout it. Just repeat it back.
For the auto-catching inside of the cycle, have you looked at Renovate? Renovate block?
We have.
Restate the question, please.
He's asked if we are looking at Renovate for the auto remediation. We have to filter the data from the Renovate because it's doing so much. It's noisy. We have to get it down. We want to get it down to just high level, just critical and high risk vulnerabilities. And the Renovate data will tell us what we need to do to remediate. But we are looking at MITRE as being kind of the single source of truth for us because they do quite a bit in remediation of these vulnerabilities. And we hope that MITRE survives.